Now, let's consider the octet rule. The octet rule states that an atom will gain, lose, or even share electrons in order to receive the same number of electrons that are found in the nearest group 8 atom. What does that mean? Well, let's take a look at our very useful periodic table as a guide. The first case we will look at is hydrogen. The group 8 atom nearest hydrogen is helium. Hydrogen has 1 valence electron, whilst helium has 2 valence electrons. So, hydrogen needs to find 1 extra electron in order to receive the octet rule stability. Our second example is lithium. It's still the same process. Lithium has 1 valence electron. The nearest group 8 atom is again helium. However, unlike hydrogen, lithium must lose instead of gain 1 electron to have the same number of valence electrons as helium. Now that is either 0 if you are counting the second shell, or 2 if you're considering just the first shell that hydrogen partially fills. Our next example is carbon, whose nearest group 8 atom is neon. So, carbon has 4 valence electrons, whilst neon has 8 valence electrons. So, carbon needs to find an extra 4 electrons to obtain the same number of electrons as neon, and therefore the octet rule stability that it desires. What about fluorine? Well, it has 7 valence electrons. Its nearest group 8 atom is also neon, with 8 valence electrons. So, fluorine has to find 1 extra electron to derive octet rule stability. Let's focus now upon magnesium, with 2 valence electrons. It also has neon as its nearest group 8 atom. So, magnesium must lose 2 electrons to have the same number of electrons as neon, with 0 valence electrons if you're considering the third shell, also partially filled in the case of the neutral magnesium atom, or 8 valence electrons related to the second shell. Finally, we come to chlorine. Its closest group 8 atom is argon. Like neon, it has 8 valence electrons, though in different shells, and chlorine, like fluorine, has 7 valence electrons, again in different shells. Chlorine and fluorine are both in group 7, and thus have similar properties governed by their desire to gain 1 electron to get octet stability, with, in chlorine's case, having the same number of electrons as argon. Maybe you can start to see why it's called the octet rule. Once electrons have been gained, lost, or shared, excluding the first shell's cases, the result is 8 electrons. Oct means 8. How does the octet rule get fulfilled? Where do these extra electrons come from or go to? When electrons are completely gained or lost to realize the octet rule, they are forming an ionic bond as a result. But when electrons are shared to meet the octet rule, this results in a covalent bond.